This lesson is about functions. It covers some basic function terminology like domain and range, and we will also a little bit get into intervals, increasing intervals, decreasing intervals, constant intervals. We will also talk about the distinction between functions being continuous or not continuous, and we will talk about one-to-one functions. All right, let's get started. First of all, domain and range. Please understand that the domain of a function is just the x values. So when we talk about domain, we are talking about x values. All right, and of course, this would be the x-axis and the y-axis. So when we look at this function, you should ask yourself, if I want the domain, how far does it go from left to right? Because that's what the x values do. They go from left to right. So hopefully you can see that this function, to the left, it goes this far. And to the right, it goes this far. So the domain will be this list of x values. And we can write that in interval notation. Got to be careful here. It goes to the left, it starts at -4. And it goes over to +3 on the x value. So the domain will be all the x values from -4 to +3. Now we have to be careful how we seal this up. If we were to use round parentheses, that would mean that these endpoints are not included. These endpoints are part of the set, so we will use square brackets to show that we are including the endpoints as part of the function. Now, on the other hand, the range is the set of y values. So when we ask ourselves what will the range be, we have to ask ourselves how low does the graph go and how high does it go. So hopefully you can see that the lowest value on the graph is here. So this is how low the graph goes because of this point. The highest point is here. So as far as y values go, this is the high mark of the function. So the range will be the y values from -2 to +1. Again, we will use the square brackets to show that the endpoints are included in the function. All right, so that's domain and range. Let's take a look at number 2, do the same thing. Again, the domain is x values, the range is y values. All right, so the x values. So for this graph, it goes from here to here. Those are the x values that are covered. So that's -1 to 3. -1 to 3. Square brackets show that the endpoints are included. I should mention that the domain and range always have to be from least to greatest. So for the domain, you have to say the numbers from left to right, -1 to 3, not the other way around. For range, you have to, again, give the values from least to greatest, which in this case will mean from bottom to top. So when I do the range, the lowest value is right here. So we hit a low of -2. The highest value is here because of this point right here. So this graph goes from a low of -2 to a high of 1, 2, 3, 4, 5. So you must put it in that order, -2 to 5. It's got to be low to high. All right, not too shabby. All right, this might be confusing because the problem numbers pertain to the graph that's above, so don't get confused. Okay, so as I look at problem number 3, it's this graph right here. Now the domain, again, I'm looking for x values when I talk about the domain, and so I'm looking for how far does this graph go from left to right. Now you see this arrow here on the end. Okay, that indicates that this graph keeps on going in this direction forever. It doesn't stop. So as I go to the right, I know that this graph ends here. It doesn't go any further to the right. But as I go to the left, this graph goes forever to the left. It doesn't stop. So basically, when I ask myself, how far does this graph go from left to right? On the left, I'm going to have to say negative infinity, all right? Because there is no end point on the left. So I will say from negative infinity to. Now on the right, it ends at positive 1. So I will put positive 1. By now, you've noticed that I used a round parentheses on the negative infinity. I told you that round parentheses indicates that you're not including that an endpoint. Well, infinity, you can never capture infinity. You can't contain infinity. So infinity will always get a round parentheses. You can't include infinity because you can't get there. But on the right-hand side, we will use our square bracket to include that positive 1. When we do the range, we will also involve an infinity. The range, we're looking at the y value, so we're looking from bottom to top. Now, the low value of this function is right here, so I'm definitely going to start off at negative 3 for the range. Now, as far as the high value, again, because this graph goes forever in this direction, that means it continues to go up. You know, I can't draw a line right here and say, oh, it stops here. No, it keeps on going. So again, I'm going to need an infinity to reflect that it starts here at the bottom, but it goes up forever. So I will say negative 3 to infinity. Infinity always gets the round parentheses. Look at problem number 4. The domain is the x values. So we are looking in this direction. How far does it go to the left? How far does it go to the right? Well, this is how far it goes to the left. All right, because of this point right here, that's the end. It doesn't go any further to the left. Now, how far does it go to the right? Well, this being an arrow means that this keeps going forever. So that means it goes to the right forever. So the domain is going to be negative 2 to positive infinity. Notice the negative 2 gets the square bracket. We're including it, but infinity always gets the round parentheses. You can't get there. Now the y values. For the range, we are asking about the y value. So we're asking ourselves, how low does it go and how high does it go? Well, it goes this high. This is the highest y value included in this graph because of this point right here. So I know that this graph goes up to 4, a y value of 4. So I will include that with the square bracket. But again, because of the arrow and this graph continues down, 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 as we're looking from bottom to top, down here is negative infinity. So I will have to say that this graph starts at negative infinity. Messed it up a little bit. It goes from at the bottom, it goes all the way to negative infinity, keeps on going, up to positive 4. So that would be the range. Okay, 2 more of these domain range problems. Again, the domain is going to be your x values. That's how far left, how far right. So this is how far left it goes, and this is how far to the right it goes. So the domain will be from negative 3 to positive 5. All right, so we will do negative 3 to positive 5. Square brackets because these endpoints are included. So that's the domain. For the range, we are looking at the y values. So instead of looking left to right, we are looking bottom to top. So this is the bottom of the graph right here. All right, it doesn't go any lower than this. That's the bottom. Now, looking at these 2 endpoints, I'm really looking at this one because this one is higher. So this represents the highest point hit by the graph. So the lowest is at negative 1, and I will use a square bracket because it hits negative 1. We'll include it. And it goes up to a height of 3. So the range would be negative 1 to 3. let's take a look at number 6. The domain is the x values. How far left does it go? How far right does it go? Well, this is how far to the left it goes. It doesn't go any further to the left than that. So that's going to be -2. Now, as far as how far to the right it goes, look at this arrow. This continues drifting. Yes, it's going down, which sort of draws your eye, but it also is drifting to the right as it goes down. So when we do the domain, we really don't care about the fact that it goes down. We just care about the fact that it goes to the right forever. So we will say -2 to infinity. Now, as far as the range is our y values. So we will ask ourselves, how low does it go and how high does it go? Well, how low does it go? Now we care about the fact that it's going down forever. So that's -infinity. Now, how high does it go? This is the tallest point, the highest point on the graph. So it goes from -infinity to 3. All right, so that's a little lesson on how domain and range works. Very basic, but there it is. Now let's add to that. I'm still asking you about domain and range for number 7, but we have to start talking about increasing and decreasing intervals. First, the domain and range. For domain, we're still talking about how far to the left it goes and how far to the right it goes. Now, even though I didn't draw any arrows on this, because this was generated by a computer, you should assume when the graph goes all the way to the edge of the picture like that, that this is meant to continue forever. So that's why the domain is going to be -infinity to +infinity. Okay? Because the graph drifts left forever and it drifts to the right forever. Now the range. The range is the y values. All right, these are the x values. So we're looking bottom to top for the range. At the bottom, this thing goes forever down. So that's -infinity. Whoa, that's not a very good infinity. Let me try again. Okay, so -infinity. The top, this is the highest point of the graph. So we'll say -infinity to 4. And we will use a square bracket because it hits 4. It gets all the way there. Now let's talk about increasing and decreasing intervals. An increasing interval is just like it sounds. It's the x values where the graph is increasing from left to right. All right, and by the way, this has to be left to right. So look, let me colorize this for you. Say if I'm starting out over here on the left side of the graph. This is my beginning point. And I want to get from here, and eventually I'm going to get all the way over here. So I'm going to travel, for a while I'm traveling on the curve like this. Now right now I am going up the graph. So that's why right now this is an increasing interval. I'm going up, 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 up. But at some point I get to the very top of the graph. If I keep going any further, I'm going to start going down, 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 down. So for the rest of this path, I am going down, 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 down. All right? Now remember, this really goes forever like that. And same thing with this. This really goes forever. So if you looked at this graph from left to right, and that's how you always have to do these intervals, the increasing interval I colored green. Because from left to right, the green part is the part where you are rising. So starting here at -infinity, and not -infinity because it's pointing down, -infinity because I'm starting here on the left. So starting from the left, going to the left forever, all the way up to this spot right here. And again, it's the x value that I really care about. And this is an x value of -1. So the increasing interval is from negative infinity to -1. Okay, that's where the graph is increasing. You know what? At negative, I really should not use a square bracket. I should use a round parentheses because right at -1, that's where it changes from increasing to decreasing. So just for a split second, at -1, it's neither increasing nor decreasing. But everything up to -1 is increasing. Now the decreasing interval is the part that I have in here in red. So starting at an x value of -1, and then continuing on forever to the right. So everything from -1 to infinity will be my decreasing interval. Okay? Again, this is a positive infinity because I don't care about the fact that this is going down. I'm putting positive infinity because it's going to the right. All right? Increasing and decreasing intervals are always left-right, sort of like domain. Okay, now a constant interval would be in a zone where the graph was flat, like horizontal. No part of this graph is horizontal, so there are no constant intervals. So I'll just put none. Now, is this graph continuous? Continuous just means there are no breaks in the graph. And so yes, this graph is continuous. There are no breaks, no gaps. Is this a one-to-one function? If I give you a graph like this, I know that this is a function because it passes the vertical line test. Okay, so if I take a vertical line and so say if I put a vertical line like this, no matter where I draw this vertical line, make it a little bigger, no matter where I draw this vertical line, it only hits one point on the graph. All right, it hits one point right here. As it goes, it's only hitting 1 point, 1 point, 1 point, 1 point, 1 point. Any vertical line is only going to hit 1 point on this graph. So that's how I knew it was a function. Now, if it's a one-to-one function, it will also pass the horizontal line test. So if I take this and I make it a horizontal line, okay, like this, does this pass the horizontal line test? Well, no, it does not, because it hits here and here. So it fails the horizontal line test, so that means it is not a one-to-one function. If it's a one-to-one function, it'll pass the vertical line test and the horizontal line test. All right, let's take a look at the next one. All right, looking at number 8. First of all, the domain. The domain is going to be the x values. So how far it goes from left to right. Looking at these arrows, I can see this graph goes to the left forever. So that's negative infinity. And this graph goes to the right forever. That's positive infinity. So that's going to be your domain. Now the range. The range is the y value. So now I'm looking for how low does it go and how high does it go. Now this is the lowest point on the graph because of here and here. So the range is definitely going to start at -2 with a square bracket because it hits it. Now, how high does it go? Don't look at this middle hump. You have to again look at these ends because these are what keep going on forever. So it goes up and up and up. That's positive infinity. So that would be your range. Now let's talk about those increasing and decreasing intervals. Remember that we always have to go from left to right. Okay, so let me start my journey here. So I'm going from left to right. So starting here, and I want to end up over here, To travel on the curve, though, I would have to go like this. Right now, I am falling, falling, falling until I get to here. So that is a decreasing interval. All right, from left to right, it goes down. So let me go ahead and record that. Okay, so my first decreasing interval is from, now this is negative infinity over here, all right, because it's starting from an arrow, goes forever. So my first decreasing interval is from negative infinity to negative 2. Remember, it's all about x values. So negative infinity to negative 2. Okay, we won't include the negative 2 because right at negative 2 is where it switches. Now, the increasing interval begins now. So, as I continue on the curve, now I'm going up, up, up. I'm rising, 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 rising until I get to here. So this is an increasing interval. So an increasing interval would be from negative 2 to 0. All right? When you mark your intervals, look at the x-axis at all times. So from negative 2 to 0, this is where the function was increasing. Okay, but then I continue my journey. Now as I continue, once again, along this area, I begin to fall, 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 all the way down to here. So that is another decreasing interval. Okay, so that's going to be from 0 to 2. All right, from 0 to 2, it is falling. But then, once again, starting from here, it starts to go up. So from here to here, it is rising. And it continues to rise forever. So my increasing interval will pick up at 2 and go to infinity. Okay, so increasing from 2 to infinity. So there are two increasing intervals that I've shown here in green. That one's bothering me. I want to try again. So I failed before. All right, it's a little bit better. So these green parts of the graph are my increasing intervals, but only look at the x values. The red on this graph, these are where the graph was falling from here to here, falling from here to here. But when I write them down, I am only looking at the x values. Okay, let's do one more. Did I say one more? I meant two more, but I'm going to go faster this time. Okay, so the domain. The domain is the x values. That's how far left and how far right it goes. So to the left, it goes to negative 4. All right. To the right, it goes to 8. Oh yeah, I should be using square brackets because it's not infinity or anything, so I can include it. So negative 4 to 8. That's my domain. Now the range is the y values. That's how low does it go and how high does it go. The low. This is the lowest point on the graph. It is at a y value of negative 2. Okay, so negative 2. This is the highest part of the graph. It's at 4. So there's my range. Now let's do the increasing, decreasing thing. Always got to go from left to right. Now, from left to right, I'm going to start off right here. No infinity this time. I have a definite starting point. But it's going to be increasing on this part of the journey until I get to this spot right here. All right, remember, these increasing and decreasing intervals, I'm only looking at x values, not y values. Don't say negative 2 to 4, okay, because those are y values. Instead, you need to look here and say negative 4 to 1, okay, because those are the x values. So this is increasing from, and you know what, I can go ahead and use the square bracket this time because it's not an arrow or anything, it's included. So it's increasing from -4, -4 to -1. Okay, and then it is decreasing. So starting here at -1. Well, you know what? It's not decreasing, is it? Better do this in blue. See how this is flat? This is what I was talking about for a. This is what a constant interval looks like. From here to here, it is flat. So from here to here, shown here in blue, that is a constant interval. So it is constant from -1 to 3. Okay, got to look at those x values. So from here to here on the x-axis, so that's -1 to 3. Now, as I continue on my journey, so far I went uphill, that was increasing. I was flat, that was constant. But then I go downhill from here to here. So that is from, starts off at 3 and it ends at 8. So decreasing interval will be from 3 to 8. Okay, is this continuous? Yes, because there are no breaks in it, there are no gaps. Is it 1 to 1? Well, to be 1 to 1, it has to pass the vertical line test and the horizontal line test. It passes the vertical line test, but for example, if I put a horizontal line right here, it hits more than 1 point. So no, it is not a 1 to 1 function. All right, finally, number 10. The domain. Remember, I'm supposed to assume that this keeps going forever. So the domain is the x values. How far left does it go? How far right does it go? Well, it goes left forever, and it goes to the right forever. So that's -infinity to +infinity. The range is the y values. So how low does it go, and how high does it go? Well, it goes down forever, -infinity, and it goes up forever, +infinity. Okay, now let's do our increasing and decreasing intervals from left to right. So starting off on the left, okay, starting off from here, I begin my journey like this, down, 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 down. So that was decreasing. So that's decreasing from -infinity to -1. Okay, -infinity, whoa, I put an 8, didn't I? All right, it was decreasing from -infinity to -1. Please remember that these are all x values. All of these have to be x values, -infinity to -1. Don't say +infinity to 0. Those would be y values, and that's wrong. Now, as I continue my journey, now I begin to go uphill. So I'm going uphill from here to here. That is an increasing interval. And I'm going to say it's going to be from -1 to 1. Okay, because here I am at -1, and here I am at 1. I'm sticking on the x-axis. But as I continue my journey, now I begin to fall again. Fall, 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 fall. So I have another decreasing interval from +1, because I'm picking up from here, to infinity. So +1 to infinity will be decreasing. There are no flat parts of the graph, so there are no constant intervals. Is it continuous? Yes, because there are no breaks in the graph. Is it 1-to-1? No, it passes the vertical line test, but it would fail the horizontal line test. So it has to pass both to be 1-to-1. So that's a no. All right, that is the end of this lesson. I hope it was helpful to you, a little brief review on function terminology. If so, a like is always appreciated. Either way, I will see you on the next video.